All right, we're going to be talking about systems of equations in today's review. We're going to be going over, basically, systems just means more than one line at a time. And whenever you have more than one line at a time, you're always going to be looking for where do those lines cross. So option one is that the lines cross. This is kind of your standard. This is going to happen, I would say, probably like 95% of the time. This is very common. And you just look at where they touch. They touch at left 2, negative 2, and up 2, positive 2.
Negative 2, positive 2.
There you go. Now for the second scenario, we end up with the same lines. Even though these two lines don't look right now like they are the same, they are the exact same. So, if we do some math and maybe we subtract x to the other side, then we'll have negative y equals negative x minus 1, and then we can divide by negative 1, and we'll get y equals x plus 1. And guess what? These two equations, they're literally the same exact equation. Sorry my handwriting is a little messy. Of course, if you graph y equals x plus 1 and the other equation, x minus y equals negative 1, you're going to only end up seeing one graph. If you hide the second equation, you can kind of see the first one underneath it. So the question is always, where do these lines touch? They touch here, they touch here, they touch here, they touch, they touch, they touch, they touch. They touch an infinite amount of times, and so we have infinite solutions for scenario B. This one's a little bit more rare, right? We'll say it's like 2% of the time. And then we have parallel lines. This is where these two lines have the same slope, so I'll use my highlighter to kind of point that out. Same slope, but they have different of the b values, a plus 3 and a minus 3, but anything that's different would count. That means that they're going to be angled the same, but starting at different places, which means they're never going to cross. It's going to be two parallel lines. They never touch. They have no points in common. This is a no solution. Now, sometimes on the SOL test, they'll show you something really simple. They'll just show you something like this. The algebraic solution says 4 equals 4. Does that mean infinite solutions or no solutions? And for us, 4 equals 4 is always going to be an infinite solution. I don't care if you're on Earth. I don't care if you're on Mars. 4 equals 4. It's always true. Now for a no solution equation, it just needs to be 4 is equal to, and really it needs to be anything else.
So 7.
Sure. 7 works great. So does 77. So does 712. So does negative 2. Anything else. And this right here is never true. That's why we put no solution. I don't care if you're in first, second grade. I don't care if you're on the moon. 4 is not equal to 7. 4 equals 4 is always true. Now, I don't really care too much for this left box. All right, it's just the same thing. Algebraic solution is just negative 2 comma 2. Whatever. A little bit boring. Yeah, but we're almost done with the first page, and it's only been about 2 minutes, so we're all right. Down here, we're going to do these questions really quick. State the solution. If it has one solution, state the ordered pair. How many solutions do we have for letter A? None, right? This is a no solutions. Sounds good. What about B? How many solutions do we have here? This is a one solution because they touch once. And if you have one solution, you must say what that solution is. So I'm going to go to the bottom, make myself some parentheses with a comma in the middle. What is that solution? Does anybody know what it is? Perfect. A nice little harmony in the back. -4, +3. Excellent. This last one, C. It only really looks like one line to me. Where the heck is the other line? It's right underneath that line. They're stacked up. It's like bunk beds, however you want to think about it. These lines touch infinite. All right, those are some easy notes. Now we flip over to the back. And here's where we actually do the math. We don't even necessarily need to do all of these questions. It says solve each system of equation. Well, I don't really want to solve it. I just want to type it in DESMOS and make DESMOS do all the work for me. Question number 1, or I guess it's labeled as D on these notes. Y equals 2x plus 3. Enter. Y equals -x plus 3. And these two lines, are they touching 0, 1, or infinite? They're touching one time. And they're touching at 0, -3. And so, question's over. 0, oh wait, was it 3 or -3? It was +3, +3.
Wait, what's the code? So, like, you see the one that got the W and the R's?
Mm-hmm.
Do you change it to X and Y?
So let's go ahead. Let's just, I mean, who cares about number, letter E? We can do that. Let's do F. We have W's and R's. If we try to keep it as W's and R's, it's not going to work. And you guys know that. 5W equal -3R plus 5. DESMOS is saying we only do it with X's and Y's. So we need to trade. But there was a secret to this, if you remember. Which one becomes X?
Which one is first in the alphabet?
Yes. So this is very tricky, or not tricky, but this is very small, I suppose. A very small thing to remember, okay? Change based on alphabet. So the first letter needs to become X, and then of course the other letter needs to become Y. So in the alphabet, is it R or W that you get to first?
R.
It's R, right? I mean, we know that W, X, Y, Z is at the very end. So the R comes first, so the R needs to be X. So I'm going to smash my X's over top of those R's. And then the W just gets the other letter, which is Y. So when we change this, the W is the Y and the R is the X. So you have to get that right on both equations. And I'll tell you right now, this is one of those things where the SOL test is on the computer. And some people, it's going to be hard to remember and trade them out perfect. If you write them down, it is so easy to do this. If you write down A, B, C, D, E, F, G, then you're never going to miss these. And the reality is, we talked about this when we did the quiz last time on this assignment, or this type of stuff. People do mess up their ABCs and get the question wrong. Yes. So 5, -2 is the answer. 5, -2. I'm going to do these really quick, and then we're just going to move on. So G says Y equals -2. That's going to be a horizontal line. -4 equals -3x minus Y. And where do these cross? Looks like +2, -2. Again, that does not take very long. If I type it in correctly, I get the answer that fast. Now H says x equals 6, x equals -4. That looks like a vertical line and another vertical line. How do you guys feel about these black and purple lines here?
Can you change one red?
Sure.
Because it's messing with my ass.
As long as it works. There you go. Sure, I can even turn off all this stuff. Look at these two lines.
Cool.
Do these two lines touch?
No. That's what we need.
They don't touch. So is it no solution or infinite solutions? No solutions.
So we just write NS?
Yeah, sure. I mean, the SOL test is on the computer, so it'll be an option for you to pick. And then letter I, again, let's just type this in and kind of see what happens. Y equals -1/2 x. plus 2. Make sure that your fraction looks correct like mine. 3x plus 6y equals 12. And I see a whole bunch of these dots. Now that's kind of a DESMOS thing. DESMOS is kind of glitching out because it's trying to tell you where these two lines touch. And the truth is these two lines touch everywhere. So DESMOS is kind of like panicking, right? I only see one line even if I zoom out. If I hide the bottom one, the other color shows up, right? Blue, red, blue, red, blue, red, blue, red, blue, red. So these are the same line. This is going to be infinite. All right, we're flying through the notes. We're now going to get to graphing systems of inequalities. Now, to be honest, this thing right here, which we studied and we learned and we almost memorized, isn't really that important because DESMOS does all the graphing for you. So when it comes to solid or dashed, just type it on DESMOS and see what you get, okay? Now, solid lines come from equal signs. So we're going to have our less than or equal to, greater than or equal to. Dashed lines come from no equal sign. So we're just going to have a plain less than or a plain greater than. Shading, above or below, it kind of makes sense, right? If you are greater, then you are probably above. So we're going to go with greater and greater. And if you are below, then you are probably less than. So we're going to go with less and less. Just put an equal sign on one of them. But again, do you really need to memorize that? Not really, right? We can just type it in DESMOS. However, as much as I don't really care about this chart, these two things here are super important. When it comes to these inequalities, you do have to use your brain and you do have to think about whether it counts as a solution or not. And here are your rules. All points within the shaded region represent solutions to the systems of inequalities. So, for example, number 1, everything in this dark area is a solution. You don't have one solution, you have an infinite number of solutions. Now, the bottom one says, all points on a dashed line are not solutions. So remember, I used to write when we did our notes here, dash, line, bad. Dash, line, bad. So, it says, number 1, this is an SOL test question. Is the following ordered pair a solution? -4, -2. That means go left 4, go down 2. 1, 2, 3, 4, 1, 2. I got it right here. And I don't think that is a solution. I went left 4, 1, 2, 3, 4. And I went down 2, 1, 2. And it is not in the correct position, right? Anything that is touching this line would be good. Anything that is in this shaded region would be good. Anything that is on that dashed line would be bad. So for example, a dot right here, good. A dot right here, good. A dot right here, good. A dot right here, bad. Now we've done this one. In fact, I know for a fact that this question was on our notes earlier in the year. So 0, 0 is right here. That is not in the shaded region. That is going to be no good. We're looking for anything that is in the shaded region. We're looking for anything that is on the solid line, but not on the dashed line. 0, 3 means go up 3. 1, 2, 3. That's right here. That is on the solid line. Check. 3, 0 means go to the right 3. 1, 2, 3. That's not even close.
Wait, how
because that means go left and right 0, go up 3. And when I go up 3, 1, 2, 3, I'm right on the solid line. Solid lines are good. Negative 3, 0 means go left 3, 1, 2, 3. That puts me right here onto the dashed line. And what do we think about dashed lines? Dashed line bad. We do not like dashed lines. No good. We've got negative 2, negative 1. And for me, this is the one that you really want to kind of learn. Negative 2, negative 1, left, left, down, looks like this. Solid line, dash line, and the point is right here. Solid line is good, dash line is bad. Does this count as a solution or not?
No, because it's close on the dash.
Correct. No, because dash line bad. Always, if you are on a dash line, you are bad. The last one, negative 2, 1, is up here, and that is clearly in the nice section, and so that is going to be a solution. Really, for me, it's this one. Make sure you know solid and dash line, no answer. No answer. All right. I hate doing packets with staples. I'm sorry, but we have one last little piece here. We've been flying through the notes, like, we've already done a front and a back, so stay with me. We're almost done here. Now, this one says shade the appropriate region. And if you remember, we used to think, wait a second, which one is above, which one is below, which one is greater than, which one is... But the truth is, just type it in DESMOS, right? Just type this in. Let's see how it looks. Let me turn my stuff back on here, the grid. Nah, actually, that's probably a good idea. So if I just type this in DESMOS, y greater than negative x minus 2, y less than or equal to 3x plus 6, that's the picture that I see, except for now it is colored. If you like the red and blue setup so that it makes kind of a purpley color, not really, but blue, red, and here is the double shaded region. And so I guess, man, go ahead. Be back quickly. I got the time you're leaving. So we're going to go with side B here. If you want a more, colorful explanation for that, I guess. We ended up coloring, as you can see, blue on that top side there. So the blue ends up here. And we ended up coloring red on this bottom side here. I'll use yellow instead. And look at the magic of colors. We end up with green in the middle. Fantastic. At least on my paper it looks green. Maybe on the screen it looks brown. Not too bad. All right. Now this one says which ordered pairs are solutions, and they don't give you a picture. How could we get a picture of this system of inequalities? Just DESMOS. So I'm going to give you some time, 1 minute, to try to do number 4. Type in the system. Once you have the system, consider the different pairs and see how you do. Okay? Cool, that gave you going to try it out? Type it in the... Try on number 4. Type it in the system. Once you got the system in there, consider is 0, 7 a solution? Is 0, 1 a solution? Michelle, you got it? You going to try it? Doing okay? Raven, you alright? Sure. We're almost done. We've got, what, 3 questions left?
Can I go after that?
She said she is in the office. I guess.
Thank you.
You're welcome.
To change your clothes so can I change?
Sure. I'm going to start typing this in. Hopefully you're working ahead of me. Hopefully you are considering whether these are values or not. I got my two graphs. If I don't like the colors, I can change it, but honestly, you know, this looks pretty clear to me. I'm going to make sure I typed them in correctly. Nice. And let's just see how we did. So the first question, here, maybe I can do something like this. There we go. It looks a little funky, but now we can see both. What do we think about 0, 7? Did we pick solution or not a solution? We picked not a solution because 0, 7 would be go left and right 0, go up 7. Here's another technique. If you're thinking, I'm not very good at these coordinates, just type in the coordinates. Parentheses 0, comma 7, it will graph it for you. And if you hit this label, it'll be even easier to find. This 0, 7, you know what I think? Not so good. So let's turn this to red and let's unlabel it. The next dot is 0, comma 1. Let's make sure we put some parentheses on that. How does this one look in here? I think it looks good. It is in the double shaded region. Maybe I'll make my other color in blue, and then maybe I can. The green is hard to see.
Purple.
How about black if it's good? All right. So red is bad, black is good. I think that looks good. So circle this. Again, if you're not good at typing or figuring out where these should be, just type them in. Parentheses -2, comma 3. How about this one right on the X? Good or not? Right on the X. On the intersection of dashed and dashed. Dash line bad. Of course, that one's going to be no good. What about 0, comma 0? That one looks pretty good. It's in the double shaded region. Nice job. What about 0, comma -1? That one is right on the line. It gave me the right color again. Nice job, Desmos, genius. -2, comma 2. This one is in the shaded region, kinda, but it's not in the double shaded region. It is in the shaded black region, but not also in the shaded blue region. So this one is going to be no solution. So red is bad, red is bad, red is bad, red is bad, and these two are good. On your paper, that looks something like 0, 0 was a good answer. This one was a bad answer. I think we only had 2 good ones. All right, and now we get to the bottom. Now, let's talk a little bit about the SOL test. I don't know if I told you this yesterday. I'm going to kind of slowly start leaking you information. The SOL test is 55 questions. Now, that is very long. That is longer than any test we've taken all year. So, if it's 55 questions, how many do you think you need to get right in order to pass?
Like 30. Because 25 is a 50.
So 25 is half of 50, so maybe a little bit more than 25.
30.
Maybe 30. Anybody want to make a guess?
27. 30.
So we're saying 30. 10 of them don't count. I don't really know how that works. I know what you're saying.
In the last test, it was like 10 was like first question, they didn't count.
Right. So there are kind of like questions that are just for the test makers so that they make sure that the questions are fair before they count. Because what if they try to put a question on for the first year and it's not very fair and all the kids by the beach miss this question because there's some weird part of it. So here's what's going on. We need 21 correct answers. Now, if you're doing the math in your head, that's not even half. And if you're doing the math in your head, that's not even close to half. If you're on Desmos and you type in 21 out of 55, that's about 38%.
Oh, but in SOL terms, it's different.
Right. So on SOL terms, the scoring is really weird, and we'll talk more about the scoring later. Here's the deal. On the SOL test, you got to get 21 questions correct, And there are about 20 easy questions that are literally labeled as easy by the SOL team. And so when it comes to the SOL, you don't need to get all the medium questions right. You don't really need to get any of the hard questions right. You just got to get the easy questions every time. Now, when it comes to solutions of systems, we get to system word problems, and I'll be honest with you, this is one of those things that is theoretically a hard question. We're going to learn it, we're going to talk about it, and honestly, I don't think it's that hard. I remember when we did it together, it took a little bit of practice, but if you can figure out how to get these questions right, if you're a student who actually tries and isn't on the phone behind the computer in the back 2 rows sitting there doing that, if you're a student who actually focuses and knows how to do these hard questions, hey, girls. If you actually know how to do these hard questions, you're basically guaranteed to pass because you're going to get the easy ones right, and if you get the hard ones, you're going to have way more than 21 correct. So, this is the secret. You learn how to do these, and then you pass. This is all about 2 different equations, okay? So if you remember doing this, we did x plus y equals x plus y equals. We want to make 2 different systems based on our information. One of them is going to be a really simple equation, and one of them is going to be more complicated. Okay, sometimes I call this like the worth question, or the worth system. So here's what we got. A farm raises a total of 220 chickens and pigs. So that's all the farm animals is 220. And we're dealing with chickens and pigs. So let's put chickens on the X here. And let's put pigs on the Y. That way, anytime we're talking... Oh, I did pig with 2G instead of an S. I used to coach with a guy whose last name was pig with 2Gs. That's funny.
Wait, so he didn't have a...
His name was Ryan Pig, P-I-G-G.
That's my favorite thing.
That's my boy. No. Coach Pig, he was the man.
Was he?
No, he was not. The number of legs of the stock in the farm totals 520. So what we're going to end up with is this simple equation is just going to be x plus y equals 220, right? This is just straight up, take your chickens plus your pigs and you get 220. However, this worth equation is a little bit more complicated because we have 520 legs, but chickens and pigs are not worth the same amount of legs. Chickens have 2 wings, which we don't care about, and 2 legs. So a chicken has 2 legs each. And what about a pig?
4.
I hope they all have 4 legs each. And that's it. We have it set up. 2 equations. One of them's nice and simple. One of them includes the worth. Now we'll see the next question has to do with money. I'm sure you remember me talking about a nickel is not half a dollar. All right, we're going to type these 2 equations in DESMOS. X plus y equals 220. 2x plus 4y equals 520. We're going to look around for where these are. Look, this is the number 200 and 500. So we need to zoom out a little bit. There we go. Where is the answer? It's always where they touch. And there it is, 180, 40. So, how many chickens and pigs are on the farm? 180 chickens.
And 40 pigs.
And 40 pigs. We have 2 people out once somebody gets back. Number 2. We have Jocelyn is back, and she has 175 in her pocket with 27 nickels and dimes. How many of each coin does she have? We're just going to go through this quickly. We've got nickels and dimes. We're going to set it up. X plus Y equals X plus Y equals. One of them is going to be very simple. Just give me the total. Your X's, which is nickels, plus your dimes, which is Y's, is equal to 27 total. She's got 27 in her pocket. Then go and do the second equation. The second equation, which is the worth. Ayana, you need to put the phone away, girl. Come on, we're coming off a tough test grade. We need to lock it in here. For the second one, which is the worth, she's got 175 in her pocket, but nickels and dimes are not worth the same amount. So, your X, which is nickels, we need to put how much is a nickel worth. Well, a nickel is worth 5 cents. We all know a nickel is worth 5 cents. But we can't leave it as just a plain 5 because 5 is bigger than 1.75. And here's where we see all the mistakes. We need a decimal, but it needs to be decimal 0.5. Remember, funniest thing Amelia's ever heard, that 0.05 is a nickel because 0.5 is half. And a nickel is not half a dollar. So we are not going to do 0.5. We need 0.05. The dime is just 0.10. That one's pretty easy. It's always the nickel that throws people off. It's 0.05. And then we type it in, we get the answer. X plus Y equals 27. 0.05 X plus 0.10 Y equals $1.75. We look at where they cross. Here they are, 19 and 8. So she has 19 nickels and 8 dimes. All right, we've got this last one here, and this one is a little bit of a switch up. Instead of a simple and a worth equation, it says that the sum of two numbers is 50, and the larger number is 16 less than 5 times the smaller. So we can just put, like, you know, the X can be the large number, and the Y can be the small number. The sum is 50, which means that if you add up X plus Y, what do you get? 50. But then we get this second piece, and it says the larger number, which we said is X, is 16 less than 5 times the smaller number. So the larger number is, that means large, which is X. The word is the equal sign, so we'll put our equal sign here. 16 less than 5 times the smaller number. Man, they've really hit us with a confusing one at the end here. If you remember less than works backwards. So you're going to flip this around 5 times, which is going to be 5y minus 16, because less than means to change the order around. We talked about that in the past. We'll talk about it again when we do writing equation review. I think we've done this enough. Let's just finish up and finish the notes. We've got X plus Y equals 50 and X equals 5Y minus 16. Look at where they touch. 39 and 11, that's the answer. X equals 39, Y equals 11, and we're done with the notes. When it comes to equations, just type them in. Remember, you got one solution or infinite solution or no solution. When it comes to inequalities, take your time and make sure dash line bad. And when it gets down here, I know that these are harder questions, but if you can figure out how to do a couple hard questions, you're guaranteed to pass.